All right, so I went over how to kind of calculate the area between two curves, but I'm ready to do some examples. So example number one, I want to find the area of the region in the first quadrant bounded by y equals x minus 1 cubed and y equals x minus 1. So notice number one, it's in the first quadrant. So that's kind of what I sketched as a graph is the first quadrant. And so what I'm going to do is, again, try to graph it and see which function actually is the one on top, because that's really important when I go in to try to solve these problems. So let me go ahead and I'll do the y equals x minus 1 cubed first. I'll do it in blue. So if I do x and I do x minus 1 cubed, let me just plug in 0. If I plug in 0, 0 minus 1 is negative 1, cubed makes negative 1. If I do 0.5, we're going to do 0.5 minus 1 cubed, which gives me negative 1 over 8, which is negative 0.125 approximately, or actually exactly. Let's plug in 1. 1 minus 1 is 0. Cubed makes 0. Then we'll do 1.5. 1.5 minus 1 gives me 1/8, which is 0.125. And let's do 2 just to kind of round everything out. 2 minus 1 cubed is 2 minus 1 is 1. 1 cubed is 1. So if I'm going to kind of look at the way this is graphed, it's starting down here, y-intercept at negative 1. It kind of curves up at 0.5. It's negative 1.25, so it's somewhere right about there. Actually, it's probably even a little bit closer, because this is a half, and so a quarter's halfway in between. That's 1/8. And then at 1, it's 0. Then it's a little bit higher, and then at 2, it's 1. So it's got that kind of a S curve almost on its side. Hopefully you guys remember that's what cubic functions look like in general, especially when it's this kind. And so I'm going to go ahead and do the other one in red. Hopefully you guys remember x minus 1 is a line. So I'm just going to plug in the same numbers and see what happens. So 0, 0.5, 1, 1.5, and 2. If I plug in 0 minus 1 is negative 1. 0.5 minus 1 makes negative 0.5. 1 minus 1 makes 0. You guys see where I'm going with this? All right, so I've got negative 1, which is the same point down here. Then I've got negative 0.5, which is right there. 0, 0.5, and 1. So it's looking like, whoop, that's not a very good straight line. That's better. And so, again, one more thing to point out, read the problem, find the area of the region in the first quadrant. So I'm not looking for this part down here in the fourth quadrant. I'm looking for the stuff that's right here in the first quadrant. Now, notice that's a pretty small area, but the good thing is now that I've graphed it, I've also seen where it intersects. Because notice we've got here at 1, 0 and 2, 1. So now I can actually go ahead and set up my bounds. I know it's going to start at 1 and go to 2. All right, let me go ahead and kind of erase what I've got and we'll work toward that. So I'm going to look at the definite integral from 1 to 2 of those functions, x minus 1 cubed minus x minus 1 dx. And like I said, you can calculate those separately. You don't have to calculate them together. You may, in fact, want to do a u substitution on this one just because they do look kind of similar. If I do a u substitution, I would make it x minus 1. So the derivative of that is just going to be 1 dx. And so pretty nice u substitution here. So it's going to end up being u cubed minus u du. The other thing you should always make sure you remember to do is check your bounds. They will have changed from 2 and 1, because if I just plug it in, 1 minus 1 is 0, 2 minus 1 is 1. So now that I've changed my bounds, I can just go ahead and finish solving this. So I'm going to have 1/4 of u to the 4th minus 1/2 of u squared over the 0 to 1 as my evaluation numbers, as my bounds. All right, so I'm going to plug those in. 1/4 of 1 to the 4th minus 1/2 of 1 squared. Subtract 1/4 of 0 to the 4th minus 1/2 of 0 squared. Now that's all just going to be 0 at the end. So that's 1/4 to the 4th minus 1/2, which is 1/2. So 0.5 is that area. Hopefully that helps illuminate what we're doing here. Again, big things to remember. Graph it first, look for intersections, set up the integral.